All right. Good morning, everyone. So I apologize that I'm not in class today, but luckily for you, you still get to hear me talk. But I wanted to take some time today to go over a little bit more in depth about the writing classes video that I had made for you guys last week that I promised we would talk about more. And I promise again, next time I see you guys, which will be next Wednesday, that we will actually take some time to go through it. I will also put these slides that I'm going to go through today up on Classroom for you. Understand we are not going to go through this entire presentation. You can see there's a whole bunch of slides here. I'm just going to go through the basics so that way I hope we develop a little bit better of an understanding based off last time. And I have a couple of exercises for you guys to work on today. And I will also put up my own answer to those as well as ask you to turn something in so I can give you some feedback so we kind of are moving in the right direction here, right? So the first thing, Java is what you call an object-oriented language, meaning, right, that most of the things that we are going to work with are objects. The idea is to create objects that we can work with, right? Objects have attributes, they have behaviors, they have all of these things we can do, right? So I thought this comic was kind of funny, that's why I put it on this front page. But let's talk about a little bit more about what I mean by object-oriented, right? So instead of just input and output, right? So if you think about your summer work where, it was get some input from a user and then do something with it and spit it back, object-oriented programming allows us to create objects that store information and have behaviors. Now, if you think like behaviors is in quotation marks there, right? Because it's not like a physical real thing. But the idea is I can create an object that does something. Maybe I can create an object that stands for a student, right? And that object can turn in work. Or maybe I can create an object that represents a car, and a car can race, right? So that's what we mean by behaviors. And really, those behaviors are encapsulated in methods. But we'll talk about that later. The bigger deal is, right, think of a class as a blueprint to create your object. So if you think about like an assembly line, right, your class are all the machines on the assembly line to create a car. The car is the object that is created by the class, right? And then we talked about, and last week in the same video that I made, an instance variable, right? It stores the attributes. So if I'm a car, maybe I come with a number of wheels, a number of seats, whether or not it has a premium sound system, whether or not it has a navigation system, things like that. And then methods just tell you what your object can do. So if I'm a car, I might have a drive, a reverse, a turn left, a turn right method, things like that, right? They're the things that your object can do, right? And then an object itself is a single instance of a class, right? So the car class, if we think about it that way, right? If I go to the next slide here, the car class can create a whole bunch of different types of cars. I can create, right, a Toyota, a Mercedes. Each one is a car, but they all have their own unique attributes, right? Like the color of your Toyota Corolla is not going to be the same color as a Mercedes C-Class or a BMW M-Class, right? The engine, the amount of horsepower is different in a pickup truck than it is in a car. But they all work off the same basic blueprint that they all come with an engine, they all come with four wheels, hopefully, otherwise we have some problems, right? They all come with a steering wheel, with a stereo, even though those things within each individual car may be different, right? So the idea is we use the car class as a big picture thing to create specific types of that, whatever you want to call it, in this case, a car, right? So another example here just to say, right, I can use the same basic blueprint to create three different objects, right? So another example, just a really simple example of a class here would be a box class or a square, right? The two things that come along, right, the two attributes or the two instance variables would be a side length, right? We would call that an integer, and a color, which maybe in this case we store it as a string, right? Using that blueprint, I can create two separate boxes, right? This smaller box is blue and it has a side length of 3. The larger box has a side length of 5 and it's red. But they both were created using the box class blueprint. So hopefully that helps to kind of illustrate. I have, one more example here. The idea is, right, we have a building class. One instance or one object that comes from the building class could be the Empire State Building, right? We have a dog class. There's a million different types of dogs. One specific dog would be Lassie, right? When you talk about computers, right, all computers come with the same basic components, but the computer that you have in front of you right now is one instance of a computer. So they're not all created the same, but they do all come with the same basic features, right? So here's a big word for you, right? But instantiated just means initialized, right? You've created an instance of this object. So when I create an object, it's created in memory and its instance variables are initialized. So when I create the red box, right, there's a space in memory for my box, and those two variables, the side length and the color, now have values stored in them, right? So, and when your object receives a message to do something, right, it's going to go look in the class blueprint for that method to tell it what to do. So for instance, if, for your car class, if you tell it to drive, it's going to go into the car class, look for the method called drive, and then execute whatever code exists in that method, right? And so this is, again, kind of a rehash about what I talked about, in the video last week, right? But we've got 4 basic parts. You have your class name, which is always the first line. You have your instance variables, right, which are your integer strings, whatever the attributes are, right? So if I'm going to create a car class, just to make life a little bit easier here, it comes with a color, a number of wheels, and a brand name, right? So it comes with 2 strings, the brand name and the color, and then 1 integer, which is the number of wheels, because maybe I bought a 4-wheel car, maybe I bought a motorcycle, maybe I bought a truck that's got dually tires on the back, so it's got 6 total tires, right? These things may change. You have your constructor, which is the physical thing or it is the part of your code that sets the value of the instance variables. It is actually the thing that is called when you create an object. And then you have your methods, which just tell you what your object can do. Right, so again, an important thing about your instance variables, they're always listed at the beginning and they're outside of every method. This is where we talked about the private keyword, about how for our sake, they will always be private, just for the purposes of the AP exam. For the purposes of real life, they will not always be private, but for our sake, they are. The key thing here is actually this second bullet point, is that those variables exist throughout the entire class. When I declare them at the very top of the class, every method has access to them by default. So I don't need to take them as parameters in a method, right? So if I have an instance variable like the number of wheels that's an integer, if I for some reason want to change that, like I'm going to add 2 wheels to my car, I don't need to take wheels as a parameter. Right? It exists throughout the class, and every other method has access to it without needing to take it as a parameter. So that's really, really helpful if you want to change those things, because you can just write a method and name that variable just by its actual name. You don't need to do anything else. Now, a constructor technically is not a method. Sometimes we call it the constructor method because it's kind of like where a string is a weird in between a primitive and an object. A constructor isn't really a method because it has no return type. Notice that second bullet point. But however, it still executes code, so we still kind of call it a method. But either way, right? It has no return type, and its name needs to match the class name. So if your class is public class car, your constructor is public car, right? So the method or the constructor name needs to match the class name exactly. So you can take parameters in your constructor if you know right away that you want to set those values, or you don't have to, right? And you can create like a default case. Like maybe my default car has 4 wheels and it's gray and it's a Toyota, right? And so when you try to create that object in another class, like in a tester class where you want to make sure this stuff is working, the thing that is called to create the object is this constructor. So let me go back here, right? So that is the thing that's actually setting the value of your instance variables. It is the thing that is used most to create your actual instance of whatever this object is going to be. So I do want to skip over because these are just the mutators and what they do. We're going to talk about this keyword when I see you in person. But I do want to talk about these modifiers a little bit, and then this video will be over for you guys, and I'll let you get to work today. Right, so a couple of things to understand. Right, the word private means it can only be accessed within the class where it's written. Now, I know I talked about that last time, but I felt like it still might have been a little bit confusing. So what that means is if I create a variable in the car class and it's private, if I go to my main class and I try to create a car, I cannot change the brand name of the car in the main class where I'm testing it, right? It's private. As soon as it's set, it can no longer be changed except within the car class. So this is the idea I use about like PowerSchool and grades, where you guys are not allowed to change your grades willy-nilly, right? Those instance variables there are private to you, right? They can be changed by somebody else who has access to that information in another class, but to you, they are private, right? Public, on the other hand, means it can be accessed directly from other classes. I apologize if you guys can hear my dog panting. He really, really wants me to pet him right now. So if I created an instance variable and the modifier in front of it was public, that means in my main class now I could change it directly. Usually we don't want that for our purposes just because it makes it significantly easier for somebody else who may be using your code later to change something by accident and can throw things off. Static is a word that we talked about a little bit when we were writing methods. But the idea is if a method is static, you do not need an object to call it. So all of the Project Euler problems that we wrote, those were static methods because I didn't need to create an object of the main class in order to execute all of that. So I hope that helps. I hope it helps to make a little bit more sense. Again, we will talk about it significantly more. I will take all of your questions on Wednesday next week. So I hope you guys have a great weekend, and I will see some of you tomorrow. I'll see all of you tomorrow, whether that's in person or online. So see you guys later. Bye.